What's up, guys? This is Demkeys, and uh, it's been a while since there's been a APv1 development vlog. I'm just gonna explain this real quick. Don't worry, I'll keep it short. Um, so first of all, we are currently on day 406. Uh, I haven't done much development on APv1. Well, me and Glow, we haven't done any work on APv1 for the past 3 months. The reason is we had been working on a side project called Fight the Cannons. The game is ready now. It's been released. It's on itch.io. If you want to check it out, I'm going to leave the link in the description, and you can go check it out. Also, those of you who are interested, I've provided the project. So if you want to check out the source code, you can do that as well. And I've also provided no provided no I've also made dev vlogs for that project if you want to see how the development was done. Fair warning, I didn't do a very good job of dev vlogging, but yeah, I did what I could. So yeah, now that that project is over, we are continuing development on APv1. Before doing anything else, or let me rephrase that, we decided to start with completing the character development, in fact. So we are gonna complete APv1 and D, both the characters, before we move forward. And yeah, I've been working on APv1's movement in the sense the follow mechanic. So I'm just going to show you that right now. Alright, so I'm going to show you the work I've done on the follow mechanic for APv1. I started out by trying to do manual calculations. Earlier we had this sort of, I want to call it static movement. Not static movement, stiff movement. When D would move, APv1 would just follow along. And APv1's movement was not very smooth. Like, you could make out that there's a fixed offset being maintained constantly. There was no sort of imperfection being introduced in there to make it look the least bit natural. So I was trying to work on that smooth follow mechanic. So after trying it out for some time, after trying to do the calculations manually for some time and getting nowhere, I decided to use the relative joint 2D component, which you can see. Just a minute, I cannot see my cursor. Yeah, my mouse was unplugged. Okay, so yeah, that's right here. The relative joint 2D component is basically it's keeping both of these game objects joined together. That's APv1 and the player game object, which is D. The result is this. Right now you have D, you have APv1 over here, and D is currently facing towards the right. So I'm gonna turn D, and now you can see APv1 gradually moved towards this point. I've also, well, okay, you've seen this sort of smooth movement with a slow speed. What happens is, if you go really far, like as you keep walking, eventually the slow speed of APv1 is going to cause APv1 to go off the screen. So to handle that problem, I'm basically checking if okay, so I've set like a max distance variable, and I'm constantly checking the distance between the player and APv1. So if the current distance is less than let's say the max distance that is allowed, then the max force, which is just a minute, which is this right here, the max force for the relative joint 2D component will be set to 10. That is if the distance is below the max distance value. and if the distance between them is higher than the max distance value, then the max force will be set to a higher value, which I believe I've set as 50. Yeah, it's 50. So it's going to be set to 50, and because the distance is constantly being checked, so eventually once the distance becomes less than the max distance, then the speed goes back to normal. To show you this in action, you've already seen the normal max force that's causing this smooth movement. Another thing that's contributing to the smooth, slow movement is the linear drag in the rigid body 2D component. I've increased the linear drag. So wait, is it called linear? Sorry, is it called linear drag or something else? Yeah, the linear drag, I've increased it. So that's why you don't have this sort of sudden movement. I'm gonna get into what's actually causing APv1 to move from left to right depending on the rotation of the player. But first I want to show you what happens when, let's say the player jumped off of this platform and landed somewhere, really deep. Then you'll have APv1 come really fast, and then eventually once the distance becomes less than the max distance that's allowed, the speed goes back to normal, or the max force is set back to normal. Okay, so what is, just a minute. Okay, so what is causing APv1 to move left and right? I've actually done this on purpose. I wanted this kind of a mechanic. What I'm doing is, I don't know if you can see the green line over here. There's a green line over here. This is basically the linear offset between, it's a linear offset property of the relative joint 2D component. So the linear offset, I'm just changing the x value to negative. When the player is facing right, then it's set to positive, and when the player changes the direction, when the player basically looks to the other side, then I change it to negative. And how I'm calculating this is I'm comparing transform.right, which is the player's transform.right, to vector3.right. And sorry, did I say comparing? No, I'm basically getting the dot product of these two values, of these two directions. And because player.transform.right and vector3.right currently are both facing in the same direction, the dot product that you're going to get is 1. And if the player turns in the opposite direction, then when you compare player.transform.right with vector3.right, the result, sorry, again I said compare. When you get the dot product of these two, the value that you're going to get, the dot product itself, is going to be -1. So that is what's helping me set this linear offset value. If you guys want to learn how dot product works, I've done a tutorial on it, so the link's going to be in the top right corner and in the description down below, so you can go check it out. What else? Yeah, this is not perfect by any means. It's very bare bones right now. I haven't done any sort of validations like what happens in this case. You can see APv1 is being hidden behind this object. So I'm trying to find ways around this. I didn't want to actually do the calculations to have APv1 actually go above the objects. If required, then yeah, I will do it. But currently I'm trying to see if there's an easier solution. I'm probably gonna show APv1 above the other 3D objects. Well, APv1 and D, just so you know, are not going to be sprites for very long. So yeah, I'm not going to be able to set a sorting order. So I'm going to have to set the Z value. Yeah, that's it. I've been working on this follow mechanic. So far, this is what I have. Seriously, the relative joint 2D component has saved me so much time. By the way, I don't know if I mentioned this, but I think I've done a tutorial on relative joint 2D component as well. So if you want to check it out, the link's going to be in the top right corner and in the description down below. So yeah, if you're interested in checking it out, go check it out. But yeah, seriously, the relative joint 2D component has saved me a lot of time. I would have had to do so many different types of calculations, handling different scenarios, which now I don't have to do. So that's great. Also, I have been working on, let's say, resizing the UI or redesigning. I don't know if redesigning is the right word over here or not. But yeah, I've been, let's just say, redesigning the UI so that it is not resolution dependent. Because from Fight the Cannons, I learned that resolution, it can how do I say this? Well, designing UI for multiple resolutions can be a little tricky. So because of that reason, we are going to stick with one fixed resolution, which is probably going to be 1280 by 720. I think you can see that here. So I'm designing the UI based on that resolution. And yeah, that's it. I'll see you guys in the next clip. Alright, so I noticed that I had mentioned the linear offset and the fact that I'm changing the linear offset in the last clip. I didn't actually show you what that looks like. So just so you can see that and you can understand exactly why APv1 is moving to this side, I'm going to show you that without going into full screen. So I hope you can see this green line over here. I'm saying I hope because I'm looking at my phone screen right now and I myself cannot see that line very well. But yeah, there is a green line joining this point right here to this point over here. And when I, let's say, turn D to that side, then the linear offset changes to this point. That's because the linear offset value is being set to negative, so that just sort of, so to speak, flips it. And because there is a low max force and a very high drag, linear drag, so APv1 takes some time to get to that point, and that is basically what causes the smooth follow mechanic. So yeah, just wanted to show that. Okay, what's up guys, this is Demkeys and we are currently on day 421 of the APv1 project. I have some progress to show you. I have been working on pretty much APv1, the character APv1. Like I've been working on stats and weapons and pretty much everything that has to do with the character APv1. Oh yeah, the right term would be character design. My bad. So with APv1's character design, I actually used a sort of applied. I'm not sure what the right term for that would be, but oh yeah, I implemented a specific software design. Unlike D's character design, where I was just seeing what works, because I've mentioned this in the previous one of the previous vlogs that you know, working on this kind of a character, an RPG character, it was sort of a first time thing for me. I've never done it before, so yeah, there were bound to be mistakes and flaws in the design. But with APv1's character design, I feel there's more of a system in place. Things are being done more neatly. Like you cannot set the, for example, just as an example, let me bring up the code. Okay, so yeah, for example, you cannot set any of the properties values, like these properties right here. You cannot set any of their values from outside the class. You have to call a function from, well, from outside the class. You have to actually call a function which is here, update stats, and then you can, for example, change the HP or change the EP, which is energy points, or the excitement points. Excitement is pretty much the equivalent of D's adrenaline. So in APv1's case, we have kept excitement. So yeah, this is just an example of the kind of design that I've implemented. And things are much more neat. So far, I haven't found any flaws with this design. Things are more structured. I've also currently I'm working on, you know what? Let me just tell you what all I've worked on so far. I've worked on the stats. That's HP, EP, excitement, also a base shoot rate. I'll get to the weapons later. Each stat, HP for example, has a capacity which can actually be upgraded. It has a regeneration rate which can also be upgraded. The same goes for EP, and for excitement we don't really have a regeneration because the excitement actually builds up rather than cools down. Rather than cools down? No. The excitement actually builds up when you attack an enemy, and it cools down when you don't. So in the case of energy regeneration, it's when you actually attack, you lose energy points, and that regenerates over time. So yeah, some of these stats are actually upgradable. Before explaining the upgrades, let me explain. Oh yeah, by the way, the regeneration also is being done from within the class itself. You call a method from outside the class. The method is regen and cooldown stats, and then it does the calculations based on the property values of some of the properties over here. What was I talking about? Upgrades, weapons. Sorry, I forgot. For weapons, okay. So what we had in mind was 3 weapons, but rather than create separate properties for each of those weapons, I figured why not just make a class called APv1 weapons or APv1 weapon and create an array of that class. This way the system is more scalable. So if we do decide to add more weapons, for example, currently I've been thinking, although there are 3 weapons, we'll give the player the choice of 5 weapons. Maybe somewhere in the future we might decide that we actually want the player to have 5 weapons. So in those cases, it's much better to have a scalable system. So I decided to do that, and the way these weapons are going to be assigned is using an APv1 weapon asset instance. Basically, you create these assets, and you can you can basically set all the properties for these assets, and these are basically weapon assets. So they are assigned to this array over here, and then this array is passed in during the initialization of the APv1 class instance, which happens in the APv1 script over here. I've also hooked up the the class properties, which are basically stats. I've also hooked them up to the AI. So let me just play this in full screen. Okay, so for example, right now APv1 is shooting its Gatling cannon or Gatling gun. I think it's called a Gatling gun. Yeah, it's shooting its Gatling gun. So as you can see, the energy is going down very slowly, and it also regenerates when I'm not shooting. Real quick, let me just assign the right assets over here. I changed it earlier for debugging purpose. Okay, so currently the Gatling gun is equipped. If I hit space, I've just set it to space. I've set the key to space for debugging. Eventually it's going to be an actual there's sorry there's going to be an actual button assigned for switching weapons. So yeah, when I change the weapon, what? Okay, just a minute. There seems to be something wrong. Gatling gun, rocket gun. Ah, okay, yeah, I forgot the system that I myself implemented. So, you know what? Before I continue, let me just mention this as well. Okay, the reason why it didn't work earlier is because let me just delete these two assets because they were there just for debugging. So these are the three guns, these are the three weapons that APv1 can equip right now. One is a Gatling gun, one is a rocket gun, and one is an energy gun. It's going to have some sort of energy ray or a big energy blast of some sort coming out of it. I'm not sure yet, but we'll figure out something. And as you can see, each of these weapons, they have their properties. First of all, there's the bullet prefab, because each bullet is going to look different, so we're actually going to have a different prefab for each bullet, and that can be assigned over here. Then there's the name of the gun. I felt that that was necessary just so we can know what the name of the gun is if we ever need to read it during runtime. Then, yeah, the weapon shoot rate. This is actually multiplied by the base shoot rate. So currently I've kept the base shoot rate 1, and that is actually upgradable. So yeah, you don't upgrade the weapon shoot rate, you upgrade the base shoot rate. And then that in turn pretty much upgrades the shoot rate for all the weapons. Then you have the EP cost. This is how much EP is gonna be lost each time the weapon fires one bullet. Then there's a weapon image, just in case it's needed. One example of where it might be needed is, for example, in the UI, when we are trying to show which gun is currently equipped to APv1. And then finally we have the unlocked property. Okay, so this is just an asset which is going to be assigned at the start of, like, when the class is initialized. So the reason I actually kept it over here as well, it's not really required, but the reason why I kept it here is so that from the beginning itself we can specify which guns are locked and which guns are unlocked, because in the upgrade process, one of your options is also going to be to unlock new weapons. So yeah, that's why we have these unlock options. So I'm going to set the unlock property for all three of them to true, and now I'm going to play the game. So this is the Gatling gun, and when I hit space, it switches to the rocket gun. So you can see a different colored bullet and a different energy cost, and also a different shoot rate. We are gonna set the damage accordingly. It's like a rocket might do more damage than the bullet of a Gatling gun, and a laser bullet or a laser thing might do more damage than both the other weapons. So I'm going to switch to laser, and as you can see, the the energy gun, it has a higher shoot rate than the rocket gun. Also, I've implemented a check to see if, basically to make sure that APv1 can only fire if its energy is, if there is actually any energy. Okay, you cannot see HP in action yet because there's no enemy attacking APv1, but HP, you'll just have to take my word for it. HP and excitement are actually functioning. What else? Yeah, in the code here, I've kept a current APv1 property, and I've also kept an APv1 weapons property, which is an array. The array is going to hold all the current weapons, and they can actually be locked weapons as well. Current APv1 weapon is actually what's going to be used by APv1 because there's a weapon switching system going on, so we required this property as well. In the weapon switching function, I just today implemented let's say a logic that how do I say this? Basically, you have 3 weapons currently, right? So if the first weapon is unlocked and you decide to unlock the third weapon in the array, the check is actually still gonna work. The weapon system will still switch to that weapon if you press the switch weapon button. It's not just gonna check for the very next weapon. So yeah, that's one of the, I don't know if I explained that very well, but yeah, that's one of the, that's a logic that I implemented today. What else? Yeah, I've been working on upgrading stats. This is the function that's going to be called after you have, I guess, clicked OK or clicked apply in the upgrade stats window. And speaking of the upgrade stats window, that is what I have to work on next, basically the UI for the upgrade stats window and also the functionality. Oh yeah, another thing that I decided to do, which I still don't know if it's gonna be, if it's a good idea or a bad idea. I'm gonna find out a little bit later because I still haven't implemented APv1's animations. I haven't implemented the audio and so on. So yeah, another thing I decided to do is pretty much have one script for all the stuff that APv1 is going to do, because this is another thing that I learned from when I was working on D's character design. This wasn't really like a character design flaw. It has something to do with the way Unity actually handles the scripts. Because I mean, if you've watched one of my previous vlogs, you'll probably remember the point where I mentioned that Unity loads the scripts in a random order, and that thing right there, that working mechanic of Unity is what was actually causing issues in the game, because sometimes one script would be loaded before, or sometimes it would be loaded after another script that actually needs that script, and that would cause all sorts of problems. So that's why I'm trying to keep one script so I don't have to worry about the execution order of any of the scripts that are attached to APv1. One exception might be any animation related scripts that I might create rather than mono behaviors. I guess they're called state machine behaviors. I might create some of those if required. But yeah, for the most part, I'm planning to keep just one just one script, so I don't have any issues with execution orders. Execution orders? No, I don't have any issues with the execution order of the scripts. What else? Yeah, I guess that's it for now. Me and Glow, we have been working on. Oh yeah, that reminds me. I have to show you what Glow has been working on as well. So I'm gonna be doing that soon. Uh, Glow and I, we have been working on the remaining portion of level 1. Level 1 is pretty much, uh, it's designed in the sense that this is a level that the player can walk through now, but aesthetically it doesn't really have any looks. It's just plain right now. So it's pretty much shapes. It's not really a level. We still have to do the actual design for the level. Glow has to draw all sorts of background, foreground, and midground layers that we are later going to put together, and then with parallax scrolling we'll give it sort of a 3D effect. What else? Yeah, I think that's it. If I remember anything else, then I'll turn on the camera again. I'll see you guys soon. Alright, so I forgot to mention this in the previous clip, so I wanted to vlog it real quick. So this is something that happened when I was actually creating this class. In this method, where I don't know if you can see my cursor, but yeah, my cursor is here. So in this method, I kept getting a null reference exception, and I wasn't able to figure out why that was. The null reference exception was occurring on this line, and I wasn't able to figure out what the issue was. Each time I would look at this line right here, though this is just the initialization of the array, for whatever reason, each time I would look at the line, I would think, yeah, the array has been initialized, and so have all the class instances. And well, that was the problem, because I was assuming that the class instances have been initialized. Again, I can't explain why. For whatever reason, I was just assuming that that was the case, and that's why I was getting the error. The best part is, I've actually made this same mistake once before in this project. This was when I was working on the cinematic sequence system. Basically, I had an array. Sorry about that. I had an array of class instances, and again, I would look at the array initialization, and I would just assume that the instances have been initialized, and this was the problem. So yeah, I just wanted to vlog that real quick.